Hey guys, my name's Robert and I'm going to show you guys how to do stoichiometry. In stoichiometry, the main new concept is using what's called the stoichiometric factor. The stoichiometric factor shows the relationship of moles of one substance to moles of another. What mass of chlorine gas would be required to consume 1.65 grams of P4? We know that we're starting off with 1.65 grams of P4 and we're trying to figure out how many grams of chlorine is required to consume it. First, we need to convert the grams of P4 to moles of P4. I got the molar mass of phosphorus from the periodic table as 30.97, but we have P4, so we need to multiply that by 4. I got 123.88. We now know that 123.88 grams are in 1 mole of P4. The grams of P4 will cancel out, leaving us with moles of P4, and we just need to take the 1.65 and divide it by 123.88. I'm going to round to 0.013. We now have 0.013 moles of P4. We need to convert this amount to moles of chlorine. And from this equation, we can see that for every 6 moles of chlorine, it requires 1 mole of P4. This is the stoichiometric factor. It shows that for every 6 moles of chlorine, it requires 1 mole of P4. The math works exactly like converting between grams and moles. The moles of P4 will cancel out, leaving us with moles of chlorine, and we just need to take the 0.013 and multiply it by 6. I got 0.078. The last thing we need to do is convert the moles of chlorine to grams of chlorine. I got the molar mass of chlorine as 35.45, but chlorine, Cl2, is diatomic, so we need to multiply that times 2. You can see that the moles of chlorine will cancel out, leaving us with grams of chlorine, and we just need to take the 0.078 and multiply times 70.9. I'm going to stop at 2 decimal places, so I got 5.53. And we now know that 5.53 grams of chlorine gas is required to consume 1.65 grams of P4 following this equation. What mass of hydrogen gas is produced from the reaction of 0.86 grams of aluminum with excess hydrochloric acid? We know that we have 0.86 grams of aluminum, and we're trying to figure out how many grams of hydrogen gas is produced. First, we need to convert the grams of aluminum to moles of aluminum. And I got the molar mass of aluminum from the periodic table as 26.98. We can see that 26.98 grams are in 1 mole of aluminum. The grams of aluminum will cancel out, leaving us with moles of aluminum, and we just need to take the 0.86 and divide it by 26.98. going to round to 3 decimal places, so I got 0.032. We now have 0.032 moles of aluminum. We need to convert this amount to moles of hydrogen. And from this equation, we can see that for every 3 moles of hydrogen, it requires 2 moles of aluminum. This is the stoichiometric factor. It shows that for every 3 moles of hydrogen, it requires 2 moles of aluminum. The moles of aluminum will cancel out, and we just need to take the 0.032, multiply times 3, then divide by 2. I got 0.048. Last thing we need to do is convert the moles of hydrogen to grams of hydrogen. The moles of hydrogen will cancel out, leaving us with grams of hydrogen. And we just take the 0.048 and multiply by 2. And we can now see that 0.096 grams of hydrogen gas is produced from 0.86 grams of aluminum following this equation.